Okay, we discussed the ramps and the traffic movement on the ramps. Okay, we discussed what are the different types of traffic flows which happen on these facilities without intersections, and this is where we stopped. So there are two main uninterrupted flow facilities. Okay, there's a third one as well, and we will discuss it in the traffic engineering course when you will take it, or some of you have already taken it. But in this particular course, we are talking about the two main uninterrupted flow facilities, which are freeways and multi-lane highways. Okay, what is a freeway? Freeway has multiple lanes, it has a median, and it is without intersections. Okay, freeway has multiple lanes with a median without intersections. Okay, that is called as a freeway. And because it is without intersections, we use a terminology for the highways which are without intersections, which is full control of access. Okay, the highways which do not have any intersections, we use a terminology for them, full control of access. Access means entry to the highway. Entry to the highway. Access. So when there is no intersection, the entry to the highway is controlled, meaning restricted. Control here means restricted. Uh, the other uninterrupted flow facility is multi-lane highway. So this one also has multiple lanes in each direction. It may or may not have a median, and it may or may not have intersections as well. Okay, or it has intersections. Okay, this one has intersections, but the spacing between the intersections is more than 2 miles. Okay, so multi-lane highway has multiple lanes in each direction. It may or may not have a median. So freeway, it was a median, and it has intersections, but with a spacing of more than 2 miles. So from one intersection to the next one, there is spacing of more than 2 miles. So this part, which is between the intersections, it becomes uninterrupted. Okay, it becomes uninterrupted. So the method which we are going to discuss here, the analysis which we are going to discuss now, they don't apply to the full multi-lane highway. They apply to the part of the multi-lane highway which is within the between the intersections. Okay, the segment which is between the intersections, and that section is more than 2 miles long. Okay. So let us start with some definitions. The first definition is for capacity. We have used this term earlier as well, but here we are using the definition which is given by Highway Capacity Manual. So in this analysis, we are following the procedure which is given in Highway Capacity Manual. So it's a manual which gives you the procedure to calculate capacity and other things for uninterrupted and interrupted flow facilities. So according to Highway Capacity Manual, the official definition of capacity is what you see on the screen. So it's a maximum sustained 15-minute flow rate. Okay. Now remember flow rate we discussed earlier as well. When you take flow and convert it to 1 hour, that is flow rate. Okay, so it is 15 minutes but converted to 1 hour. Okay, so that's why they are calling it sustained flow rate. And it is expressed in passenger cars per hour per lane. Okay, so it's a flow rate and it is expressed in terms of passenger cars per hour per lane. Okay, and the capacity is defined for a uniform segment. Okay, uniform means the part of the highway for which you are defining the capacity. Within this part, the highway design is not changing. Within this part, the highway design is not changing. So if you define the capacity from point A to point B, that from point A to point B, this much is the capacity of the route. Then between point A and B, nothing changes in the design of the highway. Number of lanes, gradient, median, shoulder, lane width, nothing changes. It remains the same. So this, when this happens, we call it the uniform freeway segment or uniform highway segment. And capacity is defined under prevailing conditions. So there are some traffic conditions which are fixed, and there are some road conditions. Road condition means uniform segment. Okay, road condition means a uniform segment. Traffic conditions basically means that you are saying that this much will be the capacity when the heavy vehicles are this much, the percentage of heavy vehicles is this much. Okay, so capacity is a flow rate. It is in passenger cars per hour per lane, and it is under a specific road design and traffic conditions. Okay, according to highway capacity manual, we also calculate something which is called as level of service. What is level of service? Again, there is a definition given. I have not put it here in the slides, but according to the definition, this gives you the quality of traffic flow. Level of service tells you about the quality of traffic flow on the highway. Okay, and level of service is defined using density of the road. Okay, level of service defined using density of the road, and density is measured in passenger cars per mile per lane. For level of service, the density should be measured or should be calculated in passenger cars per mile per lane. Okay, through level of service or through the analysis, we are trying to answer some of the important questions. When you are dealing with highway management, highway or traffic management, there are some basic questions you need to know. Okay, or the answers to which you need to know. The first thing is, what is the current performance of the highway, the current level of service. Okay, how the performance will change in the future, because in the future traffic will change. Number of vehicles may increase, heavy vehicles may increase or decrease, and so on. So what will happen in the future? Okay, at what conditions or at what time the highway will face breakdown, meaning the highway will reach the maximum level of service. Breakdown is the maximum level of service, and basically the highway will reach traffic jam conditions. Okay, so when will this happen? Okay, so in future, when the breakdown will happen. How do we design a new facility? Okay, because when you are designing the new facility, again you have to check what will be the performance expected of the facility, how much demand you are expecting, and so on and so forth. What should be the capacity of that facility? It could be the existing facility or the new facility. Maybe you have a road segment. Okay, so how do you know when it will break down? You should know the capacity. When you reach or when you go beyond the capacity, you will know that the facility will break down. So capacity is important then. And for the new facility, you will decide the capacity. And the most important parameter for the traffic engineer as well as the driver is the average travel speed on the highway. Okay, so these are some of the basic questions that we try to answer through our analysis, and you will see it being done in this chapter. Okay, so I told you about level of service. You can see different levels of service here in the table, and goes from A to F, just like your grades. So it's very easy to remember. A is, as you know, the good grade, the best one. Everybody wants it, but very few people have it. And then we have the F, which is the worst grade. This one indicates traffic jam. F indicates traffic jam. So with each level of service, you can see some description here. Okay, so A means complete free flow. You are going without consideration of other drivers, they are very far from you. B is stable flow. C is reasonable uniform flow but with low speeds. D, you are approaching unstable flow and your speed is getting lower, and E, you are at unstable flow. E is also called as capacity conditions. E is also called as capacity conditions. Okay, why it is unstable? Because at E, uh, because you are at capacity, so you don't have any extra spacing. So you want to change your lane, the flow will become unstable because of you. The other guy, the other vehicles will stop for you to make, to give you the chance to change your lane. Or let's say you have a problem with your car, you stopped, so then everybody has to stop behind you because they don't have any space to go to the other lane, and so on and so forth. So that's why the E stage is unstable. Okay, but the E means capacity basically. Okay, so until D it is stable. Okay, D is very close to unstable, but until D is stable. And then when you cross capacity, you reach F, level of service F. Okay, so for each stage they have given you the range of density. The density is between 0 and 11, you are in level of service A. You exceed 11 up to 18, you are in B. Up to 26, C, and so on and so forth. So how do you find out the level of service? This is the methodology. It has 6 steps, including gathering data from the field. So the examples which we will do now, obviously you are already given the field data. So step 1 is already done. So whatever you are doing is starting from step 2 onwards. Okay, so for example, you are doing it on your own and you have to find out the field conditions as well, the field data. So what field data you should gather? You should gather data about lane width, shoulder width, number of lanes, and other things which you see in this table. So the table gives you the ideal values of these parameters. So we talked about lane width. So what is the ideal value of lane width? 12 feet. Lateral clearance. Okay. On the right hand side, the ideal lateral clearance is 6 feet. What is lateral clearance? The distance between the lane and any roadside object. The roadside object could be a wall, it could be a guardrail, it could be a pole, anything. Okay. Any physical object on the side of the road. So on the right hand side, the distance between the lane and the roadside object is 6 feet as the ideal. It could be more, it could be less, but the ideal is 6 feet. On the right hand side of the median side, right hand side is the median side, it is 2 feet. Now keep one thing in mind, when we say lateral clearance, we are measuring from the lane. So after the lane, you may have shoulder. So shoulder is part of lateral clearance. So shoulder is 3 feet. Okay, and after 3 feet you have a guardrail. So your lateral clearance is 3 feet. Okay, after, if your shoulder is 3 feet, then you have some empty space, then a guardrail. So your lateral clearance will be shoulder plus empty space. Okay, but in any case, shoulder is obviously clear. Shoulder is part of clearance. Well, shoulder you will not have any guardrail or pole or anything. Shoulder by default is part of lateral clearance, whether it is on the right hand side or the left hand side. Okay, then we have something which we call as ramp density. Now we already talked about ramps. Okay, we have on ramps and off ramps for merging and diverging, entry and exit. So how do we find out ramp density? Ramp density means number of ramps per mile. Number of ramps per mile. How do you find out? Let's say you are doing it on this segment. So this is the midpoint of your highway segment. From this midpoint you will go 3 miles forward and you will go 3 miles backward. So total is 6. 3 here and 3 here. Okay, total is 6. Now in this 6 miles you will count how many ramps you have. Whether they are on ramps or off ramps, doesn't matter. Okay, you will count them, all of them. Okay, so you have a length of 6 miles and you counted the number of ramps. Now let's say you got 1, 2, 3, 4, 5 ramps. Okay, you have 5 ramps in your segment on in the direction which you are going to analyze. Okay, so the ramps are counted for one direction. Okay, the direction for which you are doing the analysis. Okay, so from your segment, total 6 miles, equally divided in both directions. You count the number of ramps, and then you divide by the length. The length is in this case 6 miles. Okay, with a 6 mile length. So 6 because you went 3 mile forward, 3 mile back. So if you have 5 ramps, the ramp density will be 5 upon 6. Okay, 5 upon 6. The ideal value of ramp density is 0. Okay, the ideal value of ramp density is 0. So in the whole 6 miles, no ramps. This is ideal. But obviously, it will very rarely happen that you have no ramps. So whatever ramp density, you will find it out in this method. Terrain conditions. Terrain conditions are normally or mainly linked with the gradient of the road. Okay, so gradient less than 2% is considered ideal. Driver population means people who are driving on the highway, how familiar they are with the highway, how regularly they travel on this highway. Okay, so ideal condition is all drivers are regular drivers, they are familiar drivers. Okay, so we call them commuters. Okay, what are commuters? People who are regular users of this highway. Commuters are regular users of the highway, so they are familiar, they know the highway, then the lanes, the turnings, and the ramps, and everything. Then weather conditions, clear weather is the best thing. Okay, alhamdulillah, we have most of it in Bahrain throughout the year. Incidents, anything which can block traffic. Okay, anything which can block traffic is considered as incidents. So they have given some examples. For example, vehicles which are broken down on the road, so they are stopped on the road. Police activity. Okay, there's some checkpoint, some checking happening, some something. Okay, because of which the police has blocked the road. Or it can be crashes, accidents. Okay, so these are all considered incidents. Okay, so but you can imagine anything else which has the same effect on traffic, blocking it. So that will be considered as incident. And then we have work zone. Okay, so incident, the ideal case is no incident, obviously. Then we have work zone. Work zone is construction work. Okay, work zone means construction work. So this construction work which is happening on the road or beside the road. Okay, construction work which is happening on the road or beside the road, that is the work zone. So the ideal case is you don't have any work zone, you don't have any construction activity. Okay, one of the very important parameter for the analysis is free flow speed. Okay, free flow speed. So we know free flow condition means very low traffic, right? So the best way to find out free flow speed is through observation. Okay, the best way to find out free flow speed is through observation. So you go to the highway and you actually take speed samples and you get free flow speed. Okay, this is the best way to find out the free flow speed. Okay, so you go to the highway in low flow conditions when the flow is very low, and you take samples and you do the mean, and this will give you the free flow speed. This is the best way to do it. Okay, but let's say you don't have the time, or you are talking about a future highway, you are talking about design. So in those cases, you may use these equations. Now I told you we are doing two types of highways, freeways and multi-lane highways. So the first equation which you see is for freeways. The second equation which you see is for multi-lane highways. Okay. Now, any one of you remembers what is the difference between freeways and multi-lane highways? I just told you today. Now, what is the difference between freeways and multi-lane highways? Anybody? Yes, can somebody give me the difference between multi-lane highways and freeways? No one? Okay, I can move forward, no problem.
Freeway has no uninterrupted field,
Mm-hmm.
and multi-lane highway is like it has at least two lanes in each direction.
Freeways also have at least two lanes in each direction.
It is like less restricted. I don't remember from traffic exactly.
I just told you now in this like today. So yes, multi-lane highways have some intersections, but the spacing is more than 2 miles, and freeways do not have this. Okay, so anyways, uh, if you are going to measure the free flow speed on the highway itself, then the flow should be less than 1000 passenger cars per hour per lane. This is if you don't want to use the equations, but if you use the equations, let us see what are the parameters here. We need the base free flow speed. For freeways, the base free flow speed is 75.4 miles per hour. So base free flow speed is like considered the highest for the design. Okay, the highest for the design, that is the base free flow speed. So that is 75.4 for the freeways. For multi-lane highways, it can change. It can change. Then we have the factor for lane width. So in both equations, you can see these two things: base free flow speed and the factor for lane width. Okay, so there's a table which gives this factor, this one. Okay, so this one gives you FLW, which you can use in any of these equations. Then we have factor for lateral clearance, but they are different in the two equations. They are not the same. So when you are dealing with freeway, you are only looking at the factor because of the right hand side lateral clearance. Okay, so they call it RLC, R meaning right hand side. Okay, so for this factor, we have this table. So you must know how many lanes you have in one direction, and you must know the right hand side lateral clearance. So you only need to measure the right hand side lateral clearance for the freeway equation factor. Okay, the last thing in freeway equation, free flow speed equation, is total ramp density. So I already mentioned how to calculate total ramp density. You will take 6 miles, count number of ramps, and number divided by 6 will give you total ramp density. Okay, now moving to multi-lane highways. So we already discussed BFFS and FLW. Now this is a factor for total lateral clearance. So in multi-lane highways, we don't only use right hand side lateral clearance, we use both directions lateral clearance, right and left both. So we add them together and then we find the factor. The table for that factor is where here. Okay, it's here. So total lateral clearance, right plus left, and the number of lanes. This is for 4-lane highway, 6-lane highway. When we say 4-lane highway, we mean total are 4 lanes, so 2 in each direction. And same for 6-lane, 3 in each direction. And then in this, you can see there are some other factors, couple of other factors. One is for median type. Okay, the other one is for access point density. Median types are 3: undivided, two-way left-hand lane, and divided. Okay, undivided means without median, divided means with median. And what is the two-way left-hand lane? And try to make it here. So you have a highway. In the middle of the highway, you have a lane. Okay, so maybe there are 2 lanes here and 2 lanes on the other side. Okay, and there is an extra third lane. Okay, so you have total 5 lanes in this case. In this example, 5 lanes, but you can imagine it can be 3 lanes in each direction and 1 extra lane, but two-way left-hand lane and an extra lane in the middle. Okay, that extra lane is for left turning. Okay, so let's say there is a turning here. Okay, so if I want to take the turn, I'll come in this lane and wait. I will wait as long as this side is free. When this side is free, I will take the turn. Okay, and the guy from the other direction can do the same. He can also wait here. Okay, till this side is free, and when this side is free, he will take the turn. Okay, so this is called as two-way left turn lane. For left turning vehicles who can come from any direction, and they will wait for their turn to make the left turn without disturbing the traffic. Okay, so this is the function of two-way left turn lane, and you can see the factor for two-way left turn lane is same as the divided. Okay, because this is dividing the two directions as well. Okay, the people who are going straight, okay, they will not go in this left turn lane. Okay, so that's why. Then we have the factor for access point density. So like RAM density, access point density also means number of access points per mile. But what do we mean by access point? Access points are points which are unsignalized entry or exit. Okay, or unsignalized entry points. Okay, so they are not intersections. They are not intersections. Okay, so an intersection is like this. This is an intersection. Okay, an access point will be like this. Okay, so people can only come from here with the right turn. That's it. Okay, you may be allowed to go in as well. This may be allowed as well, but there is no left turn like this. Okay, so there is no left turning. This one is not there. Okay, so that's why we call it the access point, not an intersection. Okay, there is no left turn here. Okay, so number of access points you will count and divide by the length. In this case, for multi-lane highways and for access points, there is no limitation of the length. You just count it in your segment. If your segment is 3 miles, you will count it for 3 miles. If your segment is 4 miles, you will count it for 4 miles. That's it. Okay, and divide by the length, the actual length, not 6 miles. Okay, so for RAM density, it was fixed as 6 miles. In this case, no. Okay, so this is the general description of the factors, but there is a point about the lateral clearance factor. So in total lateral clearance here, TLC means you will add the lateral clearance of the right hand side and the left hand side. So if you don't have a median, if your highway is undivided, then that means there is no lateral clearance on the left hand side of the road. You only have lateral clearance, or you may have lateral clearance on the right hand side, but obviously there is no clearance on the left hand side, because left hand side doesn't have a median. Okay, so you have your lane, and after the lane you have the other direction. That's it. So the actual lateral clearance for an undivided highway is 0 on the left hand side. Okay, but we already have a factor for undivided highway. Okay, so we already have a factor for undivided highway. So if you take this factor for undivided highway and then you put lateral clearance 0 in the equation for the total lateral clearance, you put 0 there. So you are duplicating the effect of undivided highway. You are putting the effect of undivided highway in the median type, in the median factor, as well as the lateral clearance factor. So you want to avoid this duplication. So what we do, if you have undivided highway, then you will take the median factor for undivided highway. So no change here. But in the lateral clearance, you will take the lateral clearance of the left hand side to be 6 feet. When you are adding it with the right hand side, you will take it to be 6 feet. Okay, so to avoid the duplication of effect for the lateral clearance on undivided highways, if it is undivided, then the total letter clearance will be calculated as right hand side clearance plus 6 feet. Okay, always. So it's always the same thing. The left remains always the same thing. Sorry, it's not TLC, it's RLC. Let me write it here. Okay, so this is the correct one. Total letter clearance means right hand side letter clearance plus 6 feet. Okay, this is for undivided case. This is when you have undivided. Is it understood? Is it clear? Yes. Any problem with this concept? Okay. So moving on, we have some examples. We have a freeway, urban area. We have only 11 feet lane width. Letter clearance only 2 feet. So when they are giving letter clearance for freeways, they mean the right hand side because we need the right hand side. It has a 6-mile section, total of 7 interchanges with 16 ramps. Okay, and so we have to find out the free flow speed. Now they have written here interchanges and ramps. So what is an interchange? When the highways are crossing at different levels. So one highway is above the other highway, that is called an interchange. So whenever this happens, we have to join the two highways with different ramps. Okay, we have to join them with ramps obviously, because you cannot cross from one highway to the other simply because there are different levels. So we have to join them with ramps. It may happen that one interchange may need more than one ramp. So very easy to imagine. You have two highways crossing. So you may need one ramp for entry and you may need another one for exit. Okay, you don't have two-way ramps, right? You don't have two-way ramps. So at least you may need two ramps at any interchange, one for entry and one for exit. Okay, and then you may have more than two if you are connecting it to a specific movement of the other highway. So this ramp is only for left turning, this ramp is for right turning, and so on and so forth. So you can have many ramps at one interchange. Okay, and you can see it very often even in Bahrain, where you have one highway crossing the other from an interchange. So at that location you may find at least two ramps or maybe more. Okay, so but the point here is number of interchanges is not equal to number of ramps. Okay, so the free flow speed of the freeway is given as base free flow speed minus factor for lane width minus factor for letter clearance, right hand side letter clearance, and 3.22 TRD to the power 0.84. Okay, now base free flow speed for freeways is fixed as 75.4. This is from the manual. Okay, and lane width factor for 11 feet lane width, the factor is 1.9. Then factor for letter clearance, our letter clearance is 2 feet only. So for 2 feet, and we have how many lanes? 4 lane freeway. So 2 lane in each direction. Okay, so 2 feet clearance and 2 lanes each direction. So I'm here 2.4. And TRD is given as, no, it's not given. You have 16 ramps in 6 miles. So TRD will be 16 above 6. Okay, so how much is the free flow speed? Okay, so no problems, right? You don't have any problems, any questions? All clear. Okay, let us move on. So you can do the same thing, or you can look for some examples from the books I have uploaded for multi and highways as well. Okay. Uh, Now to calculate, these are the equations to calculate the capacity of these two types of highways. The first one for freeway, the second one for multi and highways. You can see we are using the same thing in both of them, which is free flow speed. Okay, so that's why free flow speed is important, because that can give you capacity as well. So this, I think there's nothing to explain in these two equations, but after this you see another equation which is for adjusted capacity. Okay, so you may need to adjust your capacity. So these equations will give you the ideal value of capacity. Then according to the conditions in the field, you may apply some adjustments. Okay, what are the conditions which may require adjustments? Now some of these conditions require adjustment to the capacity directly, and some of them affect the speed, and you know the speed is affecting the capacity. Free flow speed is affecting the capacity. So the point is, some of them are directly affecting capacity and some of them are indirectly affecting capacity by way of a free flow speed. So factors such as lane width, lateral clearance, okay, they affect the free flow speed. uh, if you have a number of lanes which are changing, so when number of lanes change, the capacity will change. Visibility on the highway, the visibility can be because of lighting conditions, it can be because there are horizontal and vertical curves on the highway. You have already studied it in the highway course. So visibility on the curves is very critical, and it's not or normally limited, so this will also affect the capacity. And visibility can also be affected by the weather conditions. Okay, poor pavement conditions. Okay, pavement is cracked, it has holes, it has some other defects, then it will affect capacity because you cannot go at full speed. uh, if you are going across major points, okay, so you are entering a bridge, you are leaving a tunnel, okay, or there are big malls and these things, so they found that even these things can also affect capacity. uh, if you have unfamiliar drivers on the road, okay, this directly affects the capacity, because unfamiliar drivers, they normally drive more carefully because they don't know, so their speed is lower, so that will affect capacity. uh, if you are near the ramps, okay, so the capacity without ramp and with ramp will be different, and we will discuss both of them in this chapter. Presence of incidents or bug zones, we already discussed it, and this has direct effect on capacity. Okay, and we will discuss the factors for this direct effect as well. And poor weather conditions. Okay, so weather can affect visibility, and weather can affect directly as well the capacity. And again, we will discuss the factor for weather as well. Uh, Once you have the capacity, we want to know what is the current volume on the highway. So the current volume is V, capital V, this thing, okay, and then you convert it to flow rate in passenger cars. Flow rate in passenger cars. So PHF means peak hour factor, N means number of lanes, and FHV means the factor for heavy vehicles. So V is capital V is your volume, VP is your flow rate in passenger cars per hour per lane. So to do this conversion, I need to apply this equation where I'm using peak hour factor, number of lanes, and factor for heavy vehicles. We already discussed peak hour factor, and we have discussed it maybe in the highway course as well. But FHV can be calculated using this equation, where PT means percentage of heavy vehicles in the traffic, and ET is the equivalency factor for the heavy vehicles. Okay, so to calculate factor for heavy vehicles, I need two things: the percentage of heavy vehicles on the road, and the equivalency factor for the heavy vehicles. Now percentage, you take how many heavy vehicles you have, divide by total traffic, you will get the percentage. For the equivalency factor, first of all, what do we mean by equivalency factor? Equivalency factor means compared to a car, what is the effect of a heavy vehicle, single heavy vehicle, on the traffic compared to a car. Okay, so if it has the same effect as a car, the equivalency factor will be 1. But we know heavy vehicles are bigger, they are slower, so having one truck is not the same as having one car. So the equivalency factor is normally more than 1. So how to get these equivalency factors? In the highway capacity manual, they have already given us these factors in tables depending upon the terrain, because we know heavy vehicles, when they are on straight roads, on level roads, their performance is better. When they are on gradients, their performance is lower. So the equivalency factor will change according to that. So in the table which you see on this slide, it gives you equivalency factor for two conditions, two terrain conditions. Okay, level or rolling. And for both these cases, you can see the range of gradients. So level means when the gradient is less than 2%, and rolling means when the gradient is between 2 and 4%. So these are two terrain conditions. There is a third one as well, which we call as the gradient. Okay, so there are three terrain conditions: level, rolling, and grade. Okay, level rolling we already saw. Then we have three other tables for equivalency factor when it is on a grade. Okay, so this is the first one. So to get the equivalency factor, I need to know the gradient, and I need to know the I need to know the percentage of heavy vehicles. I need to know the gradient. Okay, and I need to know the length of the segment or the length of the gradient. Okay, so when you know these three things, you can find out the equivalency factor from this table. Now I told you they have, so this is the continuation of the same table. Okay, so this is up to 2.5%, then after 2.5%, this is the part. This is another table for grade, and it also has two parts, and this is another table for grade, also has two parts. So you will see 6 slides, and these 6 slides have 3 tables in them. All of them are for the same condition, grade. What is the difference between them? You can see the difference on the top here. Okay, heavy vehicles are divided into two types, SUT and TT. SUT means single unit trucks, and TT means trailer trucks. Single unit trucks are small trucks. Okay, the small trucks, the 6-wheelers we see. Okay, the ones on which you get the furniture from Extra or something. No, not from Extra, from what, IKEA or something. Okay, those trucks, the trucks which normally take deliveries for stores and so on. So those are called single unit trucks. And then you may have seen bigger trucks in the port area or near the causeway, very big trucks. They have trailers in them, and sometimes they are bringing cars, sometimes they are bringing steel and so on and so forth. So those big trucks are called as trailer trucks. Okay, so if the small trucks are 30%, the big trucks are 70%, you will use this table. Okay, if both of them are in equal amount, 50-50, you will use this table. And if small ones are 70% and the big ones are 30%, you will use this table. Okay, so for grade, we have 3 tables depending upon the percentage of heavy vehicles within them. Okay, so this is 30 and 70 within the heavy vehicles. So the heavy vehicles may be 6%. So within that 6%, what is the distribution of single unit and trailer trucks? Okay, so let us do one very quick small example. We have directional volume 30-100. So this is my V. Okay, it is normally in vehicles per hour. Then we have to find out the flow rate in passenger cars per hour per lane. It's a 6-lane freeway. Okay, so number of lanes in one direction is 3. Peak hour factor is 0.92 and heavy vehicle adjustment factor is given. We don't have to calculate, they already did it for us. So FHV is 0.83 and peak hour factor is 0.92. Okay, so my VP will be 3100 divided by all these things. Okay, so how much is that? Yes, how much is BP? Yes, how much is this? Okay, so this is in passenger cars per hour per lane and this is flow rate now. Okay, so this will be not called as volume, it will be called as flow rate. Okay, so then now we move on to the analysis for level of service. Okay, so for this analysis, we have to use these equations. Okay, first of all, have a look at the graph. This is a graph between speed and flow rate. Okay, a typical graph. So on this graph you see there are inclined lines which are showing level of service as well. But you can make this graph yourself as well. Or let me explain the equations first. Okay, so you calculated VP now. Okay, the next thing you will do is calculate breakpoint. Now if you look at the graph, it will tell you what is the breakpoint. Breakpoint is this one, this point. For this curve it is this point. Okay, what is this point? When you see the speed starts to go down, this is breakpoint. Okay, so how do we define breakpoint? The point after which you see the decline in the speed. Before this point the speed is free flow speed. Okay, so when you are doing the calculation for capacity and level of service, the first thing you will do is you find out VP. After finding out VP, you will calculate breakpoint, and the breakpoint depends upon free flow speed, speed adjustment factor, and capacity adjustment factor. So 3 things: free flow speed, we already know what is free flow speed, how to calculate it, and so on. Then we have 2 adjustment factors, one for speed, one for capacity. So once you calculate the breakpoint, you will compare it to the flow rate you have. Okay, if your breakpoint is more than the flow rate, so you are behind the breakpoint. Behind the breakpoint, we know the speed is free flow speed. Okay, the speed is free flow speed. So I'll put speed equals to free flow speed. If your flow rate VP is more than the breakpoint, then you are in this zone, the curve zone. Okay, so then I need to use this equation to calculate the breakpoint. Okay, so I will use this equation to calculate the breakpoint. What are we using in this equation? Free flow speed, speed adjustment factor, capacity adjustment factor, and capacity of the route. Okay, so this equation will be used when the flow rate is more than the breakpoint. Okay, so you calculate flow rate, you calculate breakpoint, you compare between them. Either you are here or either you are here. Okay, if the breakpoint is more, your speed is free flow speed into adjustment factor, and if your breakpoint is less, flow rate is more, then your speed is this whole equation. Okay, and then once you have found the speed from here, the density will be calculated as flow rate upon speed. Okay, so either the speed is the first one or the second one. So you find out density, and if you know the density, you already have the ranges of density for level of service, these ones. Okay, so you find out free flow speed, then you find out VP, then you find out breakpoint, compare, and I already showed you the equation for capacity as well. And then you will see the condition. Based on condition, you will calculate the speed, then the density, then you go back to the table of level of service. It will give you this density belongs to which level of service. Okay, so this is the whole procedure. Now these curves which you see in front of you, they provide a more convenient way of finding out the level of service, because they already plotted the curves, but it can only be applied where the free flow speed matches the one on the curve. So you can see these curves are for free flow speed 55, 60, 65 and so on. So if your free flow speed, actual free flow speed doesn't match these values, then you cannot use these curves. Okay, so but let's say your free flow speed is 60, let's say. Okay, so how to use the curve? You will go to the curve of 60. Okay, and then you will look for your flow rate VP. Okay, so you don't need to use the equation for S, you don't need these things. Okay, you will directly look for your flow rate. So let's say my flow rate is 1000 and my free flow speed is 60. So from 1000 I go up 60, I'm here. Okay, so my level of service, you can see this is level of service B. Okay, so if you can follow the graph, if you can enter the graph and you find your free flow speed, then it becomes easier for you to find out the level of service. Okay, how did they plot this graph? We will discuss it in detail in the traffic course. I just realized that traffic course is compulsory, so some of you have already taken it. So then you know how the graph is plotted, and some of you will take it, and I will explain to you in details there. So there's no point wasting time here. So I'm just telling you the direct method here. Okay. Any problems? Any questions? Okay. So let us move on. Using the graph, they have given us the value of capacity and the speed which you will get at the capacity. Okay, going back to the graph, where is capacity? Capacity is the end point. This is the point. Okay, this is called capacity. These points are called capacity. The end points of the graph are capacity. Okay, and these values which you see here, they are the values on the graph. Okay, they are the values on the graph for speed at these points. At the end of the curve, what is the speed? Okay, if you want to calculate it yourself, so let's say you have a speed which is 51, so 51 is not here. Okay, so what I will do, I will calculate capacity. Remember I showed you the equation of capacity, and you put this capacity as C and as VP. Okay, so C and VP will both be equal to capacity. So this will be the this is how you will calculate the speed at capacity using the equation. Okay, but this is the end point of the graph. Okay, so again these are for these graphs, the capacity values and the speed values. Okay. Okay, we can do it. We have existing 4-lane freeway. Free flow speed is given. Volume is given. Trucks, their what is the distribution, the gradient, the length, the peak hour factor. We have to find out the level of service in the peak hour. Now the free flow speed matches with this one, 70. So I will use the curve directly. That's why it becomes easier. But the first thing I need to do is I have to find out VP here. Okay, if I go to the equation of Vp, I need the FHV. Okay, so I need percentage of trucks and the equivalency factor for the trucks. Percentage of trucks is given 6% trucks. Okay, then I for the gradient 2.5% gradient, 1.25 mile length, and 30-70 distribution of small trucks and big trucks, single unit trucks and trailer trucks. Okay, so FHV will be 1 divided by 1 plus 6% trucks. Now I need the equivalency factor. Okay, so 30% single unit and 70% big one. So this one. Okay, the gradient is 2.5%. So I'm here. The length was 1.25 mile. Okay, 1.25. So this one. So 6% trucks is here. 1.25 is here. So my factor is 3.36. Okay, so 3.36 plus 1. This will give me the FHV factor. Okay. Then after you find out FHV, your Vp will be 1 divided by, not 1, the volume, which is 2000 here. Volume is given 2000. So 2000 divided by peak hour factor 0.92, number of lanes in one direction. So 4 lane means 2 lanes in one direction. Multiply by the FHV factor. Okay, this will give you the Vp. After Vp, now you can directly use the graph. Okay, so if you tell me the Vp, then we can proceed to the graph. Okay, for the rest I will do the manual attendance, so don't worry. So what is the value of Vp here? Okay, so if I go to the graph, I have 70 miles per hour, so this one, and 1300 something is somewhere here. Okay, I cannot be precise, it's somewhere here. So I'm here. Okay, so my level of service is C. Okay, so in this case I can directly use the graph because my free flow speed matches with the curve which is given. Okay, and again I explained to you the full procedure, and I already told you that in traffic course you will take it in more detail. Okay, so we are just using the direct process here. Okay, because so that we can move on to the new topics of this course, the specific ones for this course. Okay, any questions, any problems?